everyone. This is NagaLakshmi Devi, Assistant Professor, Department of Electrical Engineering, IARE, Hyderabad, Telangana. Today's topic is Generalized Cauchy integral formula. This is the last topic in that module. Now here the total number of problems are there. What is the formula here? It means. Now the first one, evaluate using Cauchy integral formula. First of all, we can use the Cauchy integral formula. What is the Cauchy integral formula? That is integral f of z dz by z minus a is equal to f of z naught equal to 1 by 2 pi I. Now cross multiplication, this one we get f of z dz by z minus a or z naught. Z naught is equal to 2 pi I into f of z naught. This is the Cauchy integral formula condition. Now here the generalized Cauchy integral formula means in each and every term it has in power n plus 1. The formula is f of n of z naught is equal to n factorial by 2 pi I into integral f of z integral over c. F of z dz by z minus a z minus z naught to the power of n plus 1. This is the condition. Here n plus 1 terms are there, then we can derivative up to n terms. So we can derivative up to nth derivative. N plus 1 terms we can derivative nth term. Okay, this is the total condition. Now f of z dz by can be written as this, can be also written as f of z dz by z minus z naught to the power of n plus 1 is equal to 2 pi I by n factorial into f o n of z naught. This is the generalized Cauchy integral formula. This one. Now it comes under Cauchy integral formula onwards. Now Cauchy integral formula, this one. Now the second derivative, third derivative, fourth derivative up to nth derivative we get this one. Now the first condition here, by evaluate using Cauchy integral formula. Here they are not given, sometimes they are given generalized Cauchy integral formula, sometimes they are not given generalized Cauchy integral formula. Already we are see this one in the earlier session, that is Cauchy integral formula and generalized Cauchy integral formula theorem. Now Cauchy, by using Cauchy integral formula, here it will be n1, that is Cauchy integral formula. Now here it is above 1 means that is generalized Cauchy integral formula. Now here f of z is nothing but sin square z. It is analytic. Now inside the circle mod z equal to 1. Now inside the circle they are given mod z equal to 1. And at the point z naught point is pi by 6. This is the z naught point. Already we know z minus z naught the condition. Here z naught value is pi by 6. Now the 0.5 is lies within the C. It is inside the C. That's why. Now the formula is 2 pi I. The formula is integral f of z dz by z minus z naught whole power n plus 1 equal to f of z naught f power n of z pi into 2 pi I by n factorial. Now here n factorial means 2 factorial. 2 factorial means 2 pi I by 2 factorial. 2 factorial is nothing but 2 get cancelled. 2 pi I only. Pi I. Now f power n means here degree is n plus 1 n means this is 3. Here n is nothing but 2. 2 plus 1 equal to 3. Here n equal to 2. That means here f power 2 of z naught. Okay. Here f of z, that is nothing but z. Then second 2 times derivative f of I. F square of z means here that is total is f of z now. Z is nothing but dou square by dou z square into sin square z. Now that is the condition. Now by using Cauchy integral formula, that is the Cauchy integral formula. Now the solution is pi I into 2 cos 2z. The limits are z equal to pi x, then pi I into 2 cos 2 into pi by 6. Z is nothing but pi by 6. Now this is the condition. Now the angle is 2 pi by 3, that means pi by 3. Pi I into 2 pi into cos pi by 3 is the final solution. By using generalized Cauchy's integral formula, we get this one. Now this is the solution. Earlier it is n factorial by 2 pi n. Now cross multiplication we get 2 pi I by n factorial. Here n is nothing but 2. That's why 2 factorial. Then this is the final solution. 2 pi I cos pi by 3 is the final solution. That one, this one same. Now that is the conclusion. Now this is the first problem of the generalized Cauchy's formula. This is the first problem completed. Now the second one. Now the second one. F of z equal to e power 2z. Now 1 minute. What is the second problem is integral over c e power 2z by z plus 1 to the power 4 dz, where c is the cycle mod z equal to 2. Here mod z equal to 2 is the given cycle. This is outside the ASN. Here this one is also outside the ASN. For example, this is the given condition z equal to minus 1. Now the cycle of the condition is z equal to 2. That is the outside the cycle. That it is Cauchy's integral formula is satisfied. Otherwise, it is Cauchy's integral theorem that becomes on 0. Now, e power 2z. E power 2z is f of z. Mod z is the circular point. Now, z equal to minus 1. Why? Because z minus z naught. Now, here z plus 1 is there. That's why z naught value is minus 1. It lies inside the C. This is the condition. Y inside means z equal to 2 is the outside the region. Inside the region is z equal to minus 1. Now, Cauchy's integral formula. Again, here the power is 4. That means n equal to 3 plus 1. That n equal to 3. N equal to 3 here. N equal to 3 here. That means formula. Integral f of z dz by z minus z naught whole power n plus 1 equal to 2 pi I by n factorial into f power n of z. Now, applying that one. Here n is nothing but 3. F of z means here that is e power 2z by z plus 1 power 4 into dz. 2 pi I as it is 2 pi I. N factorial means here it is 4 is there. That means here n equal to 3 plus 1. N equal to 1. N equal to 3. That's why that is 3 factorial into f power. Here 4 is means here it is n plus 1 means n is the order, degree. Order, not a degree, order. Then this is 4 means here order is 3 of z. That means 2 pi I by 3 factorial means 3 into 2 into 1 that is 6. 3 times e power 2z. Dou cube by dou z cube by 3 of e power 2z. 2 pi I by 6 means that is 2 pi I by 3. First time derivative 2 z by 2. Second time derivative e power 2z by 4. Third time derivative e power 2z by 4 into 2 8. Overall pi I e power 2z by 3 into 8 24 is the final answer. Is the final answer. That is the final answer. Now, this is another method. In case of here, I am not using generalizing means z minus pi I we are considering like that. We are shifted in another method. Okay, this is also another method. We are solving that also. Pi I into e power 2z by 24 is the final solution. This is third one. Now this is third one. Yes. This is third one. Oh, already you are not substituting in the condition. Pi I by e power 2z by 24. This is third one. That is z plus e power z by z square plus pi whole square. That can be split into e power z by z plus pi I whole square into z minus pi I whole square. Is not analytic. Why? Because z is always pi less than I plus or minus pi I. Here both, however, the both z equal to plus or minus pi I is not lies inside the cycle. That mod z equal to 4. Now the inside not lies inside the cycle. Then the condition is e power z by z square plus pi square whole square dz is converted into minus 1 by 4 pi square into integral over c. I am splitting into two individual parts. This is the first part and this is the second part. Now e power z by z plus pi I whole square is the first part dz minus partial fractions, completion. After completion of the partial fractions, we are solving like this. Integral over c e power z by z minus pi I whole square dz. Now the final solution is 7 by 2 pi cube I by I into integral over c e power z by z. This is substitution. Cautious in formula, that is 2 pi I by I n factorial into f power n of z naught. Here n is nothing but square, that is 1. That means e power z as is e power z and remaining. Now similarly that also. Now substituting each and every term, each and every step. That is the final solution. Here, first part, I am substituting 2 pi I, n factorial is 1 factorial, n power here square is there, that is n factorial, f power of minus pi I is the function of e. Then similarly here also substituting that one z naught value, then we get this one, f of z naught value is minus pi I plus pi I, substituting that one, we get this final solution. Next one. Next problem, if f of z equal to integral over c 4z square f of z naught equal to integral over c 4z square plus z plus 5 by z minus z naught dz, where c is the ellipse, x square by 4 plus y square by 9 equal to 1, find the values of a value. If f of 3.5 and b value f of I comma f dash of minus 1 and f double dash of minus I. Now the solution. Now first solving the first step. The given condition. What is the given condition? F of z equal to f of z naught equal to integral over c 4z square plus z plus 5 by z minus z naught dz. Now the first step is f of 3.5 is the given condition. Substituting z naught value is 3.5 only. Integral over c 4z square plus z plus 5 by z minus 3.5 dz. Now here since z equal nothing but 3.5, I am substituting that only. Is only singular point of 4z square plus z plus 5 by z minus 3.5 and it lies outside the c. It lies outside the c. Why? Because the given condition is minus 2 to 2. Now it is outside the ASEAN. Now we are solving that problem. That is 3.5 is outside the ASEAN. Therefore, it is analytic. Therefore, 4z square plus f of z. The given f of z naught is analytic everywhere within C. Hence, by Cauchy's integral theorem, we have directly it is 0. It is outside the ASEAN. The given function is minus 2 to 2. The z value is 3.5. Not here. It is lies on outside the ASEAN. The given condition is outside the ASEAN, but it is lies on inside the ASEAN. It is not valid. Now this is totally 0. It becomes the problem given on 0. That is Cauchy's theorem is satisfied. F of 3.5 is 0. Now similarly we are checking down second one. Since f of z equal to 4z square plus z plus 5 by z minus, here the given condition is I minus I and plus I. I minus 1 minus I. All lies within the cycle C. Now Cauchy's formula is all are inside the cycle. Now substituting 2 pi I into f 4z square 4z naught square plus 4 z plus 5. Now substituting each and every one individually. This is the equation number 1 or something we can consider. That means 2 pi I f of, here the power is 1 only. That's why f of 4z square plus z plus 5. Now substituting 2 pi I f of 4z naught square plus z naught plus 5. In earlier also we are substituting that one. Here we can see here. Here the final solution is like something we get pi I into something 24 by something we get that one. In here z naught means we are substituting pi I In that also we are substituting that one, we get the solution. Now here also compulsory we are substituting z equal to z naught value. Compulsory, now each and every one we are substituting z equal to z naught value in that equation. This is the final solution. Now substituting each and every term. First of all, z naught value is first they are considering I, second is -1 and third is -I. First I value 2 pi I f of, now substituting directly, that is 2 pi I z naught value 8. First derivative of this one means 8 kada. Now this derivative is 8 z naught plus 1. Now substituting z naught value here, z naught value equal to 1 first, they are considering 1. Now considering here it is first we are considering that f of z double dash also. Now double dash is 16 z naught pi I. Now similarly substituting each and every term here. First of all, f of I equal to f of I, that means 2 pi I into -4 plus I plus 5. Substituting I here. Now substituting f of -1. I completed, minus I also completed. Next f of -I. That totally we get the 16 pi I. Here this is the given function f of z. Now derivating the f dash of z, that is 2 pi I as it is. For power is square, I think. Which one is power is? The power is, okay, now here the given is f of I, f dash of I, f double dash of -I. Okay, the given solution like that. F of I, no, f dash of I, that means I am substituting 2 pi I. Now dash means 4z square. 2 derivative of first derivative, that is 8z plus z derivative is 1. 5 derivative is 0. That's why that one. Next f double dash of -I, -1. That's why that is again derivative of this one. That is 16 pi I. Here f double dash is only 8. 8 into 2. Total 16 pi I. Now f of I equal to substituting this one. Next f dash of -y -1. Next f double dash of -I. F double dash of -I means 16 pi I into -I. Here there is no I z value. That's why I am not substituting f double dash of I -I. 16 pi I only. That's all. Here there is no z. That's why I am not substituting that. Total, this is the condition. Here 8z is the z value -1. 8 into -1 plus I. Total it is -8 plus 1, total 7. 7 into 2, 14. -14. Total this is -14 pi I. Finally, f double dash of -I means it is 16 pi I. I am not substituting z value. Why? Because there is no z value. That's why it is only 16 pi I. I am not substituting that one. Individually we are calculating like this. This is f of z. First of all, they are given f dash of z, f double dash of z. That's why I am calculating f dash of z and f double dash of z. We get this one. Now, earlier problem, 3 parts are completed, I think. Yes, 3 problems are completed. Here z square plus pi square whole square also completed. Now e power 2z by z plus 1 whole power 4 also completed. Now all are completed. Now this is the generalized Cauchy integral formula. Here by using Cauchy integral formula, we are solving generalized Cauchy integral formula only. Without Cauchy integral formula, we cannot find the generalized integral formula. What is the difference between these two means? Here the power of denominator z minus z naught to the power of n plus 1 means it is generalized Cauchy integral formula. Here n is equal to 1, that is Cauchy integral formula. Now all problems are completed. Total. Here after completion of the solution, I am substituting plus or minus pi I compulsory. Why? Because that z value is minus plus or minus pi I. That's why I am substituting that one also. We get this final solution I by pi. Now the third condition completed. Now this is another problem. Here the ellipsoid is x square by 4 plus y square by 9 equal to 1. That is ellipsoid. That is upper value is y axis is 3. That means 9. 9 means it is b square. That is b value is 3 minus 3. Now this is x square by a square. A square value is 4. That is a value equal to minus 2 plus 2. Now the given condition inside the Asian, here that is 3.5 is inside the Asian. 3.5 is there. That is inside the Asian. Then that's why, okay, inside the Asian, that's why it is not condition, the function is 0. Here Z naught value. This is Z naught value. Z naught value is 3.5. The given condition is minus 2 to 2. Okay, that is inside the region, that's why it is 0. Always the circle is outside the region, the Z naught value inside the region, but it is outside the region. Here, fixing is here. The Z naught value fixing here, but here 2 is inside, it is not correct. 3, for example, here Z naught value may be less than 2, that is 1. We are solving the problem. Less than minus 2 or less than 2 condition, we get the solution. Here the Z naught value 3.5 is more than, it is beyond, not in beyond the limit, it is within the limit. That's why it is not satisfied. The condition is not satisfied. Directly here mod C here not given directly, where mod C is given the 2 in x-axis, 3 in y-axis. But Z naught is inside the region. That no, we can solve the problem. But the given Z naught value is 3.5. That is the not inside. Always outside the region is these 2. Okay, but in this problem, Z naught is outside the region. That's why it is not satisfied. Next remaining part also, remaining f of z. They are the given question asking like here f of 3.5 is completed, f of I, substituting that one, f dash of minus 1, f double dash of minus I. F dash of I means this one, f dash of minus 1. Substituting this is f of z, f dash of minus 1 means derivative of this one, that is 8z plus z derivative is 1. Now substituting minus 1 here. Already 2 pi is there. Minus 1 means minus 7. Overall minus 7. Minus 1 substituting here, it is minus 8 plus 1. Minus 7. Minus 7 into 2 pi I means minus 14 pi I. Okay, next f double dash. 8z means that is only 8. 1 derivative is 0. Overall before 2 pi I is there. Now total 16 pi I. That is f double dash of minus I. But we can't substituting minus I. Why? Because there is no z value. Only 16 pi I is there. I am not substituting that one. That's why here f double dash of minus y we can't solving. Only solution of these two only. Minus I is direct substituting here. F dash of 1 is substituting here. That's all. That is the problem. Last final solution. These are the final solutions. This is the complete generalized Cauchy's integral formula. Already Cauchy's integral theorem completed. Cauchy's integral formula is also completed. Generalized Cauchy's integral formula also completed. In before completed line integral conditions also. Okay, line integral continuation, these three also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.